So the second unit, or the second half of the module 2, is to deal with the OpenGL. OpenGL stands for Open Graphics Library, and in order to write some programs, we need some functionality from OpenGL. So some of the inbuilt functions are available in OpenGL, which is used to generate the programs. And here in this particular module, we'll be looking into the concepts of the OpenGL when it comes to the architecture, what are the states, and how the flow will go on. We'll also look into some functions, types, and formats, and a simple program. So as we all know, there is something called as modes in graphics. The first one is the retained mode and the immediate mode. Immediate mode is when the thing should happen at that particular time. Meaning when I want to draw, the CPU has to send the information to the GPU to make any drawing, whatever the changes which we want will be sent immediately. Right? So the next thing is what happens when we draw. So once we are done with the drawing, the geometry on the GPU will be like discarded, meaning it is not used as of now. And once the major bandwidth, once drawn, the geometry on the GPU will be discarded. There requires good amount of bandwidth between the CPU and the GPU, because those both two are separate hardwares. So CPU is central processing unit and GPU is graphical processing unit. So both has to be in sync. So the bandwidth should be very good between those two units. So minimizes the memory requirements on the GPU when it comes to the immediate, because most of the things are taken care by the CPU. So retained is nothing but most of the things will be sent to the GPU straight away, and it is stored. So when directed by the CPU, only then it will be displayed, whatever the things which you want. So the next thing is CPU made transformation to use the geometry, minimizes the data transfers. Why? Because the GPU now needs enough memory to store the geometry. So retain and the immediate mode goes in this way. History is very simple. The API, the IFIPS, was the committee which was formed in 1973 to deal with the API. Initially, we had only two-dimension APIs to deal with the graphics. Later, it was transformed to two-dimension as well as three-dimension in 1980s. And to look forward, we have some FIGS and the X. FIGS is for the programmer's hierarchy graphics system, and wherein after 1980s, most of the people actually started using the computers for generation of two-dimension, three-dimension images. And X refers to late 90s. Windows was one of the supporting medium for graphics. So Windows system separately, it was written, right? Then FIGS and X both combined, we call it as PEX, right? So currently we do not use it. So we nowadays use only GL, so graphics library, and that too the free version which is available, which is called as OpenGL. So to start with the OpenGL in 1992, graphics library was introduced. It was a platform independent API, meaning it was available in most of the operating system. And to deal with the performance, to deal with the rendering. So here we see the concepts of rendering. Rendering refers to we wanted a particular system which will do the job very fast, and the dependencies, right? Dependencies refers to most of the hardware dependency, software dependency. So it was taken off, right? We wanted a simple graphics library which takes care of many things. And yeah, the Windows, dealing with the Windows, and to avoid the system dependencies and immediate mode system that later added into the retained mode functionality. And yeah, this is where we actually stopped in the last class. So performance is achieved by using the GPU rather than the CPU. Why? Because CPU has been overhead of already maintaining an operating system and dealing with the architectures of it, right? So controlling the GPU through the programs called as shaders. We also had some the rendering process which was taken care, and which goes through the block diagram which we can see below. So we had the vertices which has been generated by the CPU. It now needs to be processed. So all these four blocks which you actually can see are with respect to the GPU, right? So vertices, once we get the vertices from the storage, these vertices are present in the secondary storage, right? So these storage has to be put into pixels, meaning this has to put on the display ultimately. So how exactly? The first one is we had the vertex processors, and once the vertex has been generated, the clippers take care whether if it is falling outside the screen, it will be trimmed off or chopped off, and any of the vertices or any of the sides are within the particular display, they'll be used and they'll be assembled. And next comes the rasterization. Rasterization is actually a process which is converting each particular data which has to be put on the screen into pixel. And there'll be a fragment processor based on the each fragments. The data will be sent to the display in the form of a pixels, where the pixel will have the information about what color should be applied to each cell. So we have RGB. Uh, um, so individually we have 255, 255 and 255 separate. That is 2 power 8, 2 power 8, 2 power 8. So we have around million colors to deal with respect to the pixels. So in 2009, many changes happened. Only thing which is required here is the backward compatibility, which we have to see, because any newer versions which we see, it should always support the previous older version. That is important. So many versions came into picture, like 2.1, 3.1, 4.3. Later, we also had this graphics system supporting our supporting in the web related applications also. So WebGL was also introduced, and where the browsers also started supporting the graphics in their system, and to give the smoother user interface. So next, these are yeah. So this is about the OpenGL library. So OpenGL 32 is a separate set of libraries which has been dedicatedly given for Windows, and most of the libga.a is available for the Linux systems. So the utility library, we had the OpenGL core, and will only work for the legacy code, that is for the older code, right? So later what happened was, yes, they wanted a separate graphics for the newer updated version of Windows. So GLX is available for the X Windows system, that is the old Windows system. Later it became WGL and it became AGL for Macintosh. So this is where the things which we use today. So we have something called as GLUT. GLUT stands for Graphics Library Utility Toolkit, and it provides the functionality common to the Windows, meaning what are the things which it can do, what a GLUT can do. It can open a window, it can get the input from the mouse or keyboard. It can get the inputs from the menus. It also started generating the event-driven operations. So the code is portable, meaning the code which has been generated in one machine can be used in other machines also, where the GLUT lacks the functionality of a good toolkit for a specific platform. So at that time, we didn't have the slide bars and other GUI widgets. Now it is available. So free GLUT has also come. So some functionality may not work, but it can be fixed when we work with the updates of GLUT, right? So we also have some graphics library extension Wrangler. So we're adding few functionality. So this is the graphics system as a black box, which we actually see and which we actually use it, right? We have the application program on the left, where most of the applications nowadays, in fact, all the applications today has a GUI version. The application program will actually ask for the function calls, meaning it has to get the built-in libraries, built-in codes. From where it has to get? It has to get from the graphics system. So the application program will make a call to the graphics system asking for the related functions, and graphics system will return back the data which is asked by the application program, and it will send it back. The other thing is the GLUT also supports the input output devices. So graphics system will send the output towards the output devices. Mainly it can be a screen, monitor, television, or it can also be a file. Apart from the generation of the output, the graphics library also has the functionality of getting the input from the input devices, meaning the mouse, the keyboard also can send the information to the graphics system, and these inputs can be utilized by the application program. Very simple thing. What I can do is, if you want to draw a line from one point to another point, the application program will ask the graphic system to get the information about the line and to draw both the functions, and graphic system sends those information to the application program. Apart from that, graphic system also helps us to print the line from one point to another point and display it on the output screen. So we majorly have 7 types of functions: primitive, attribute, viewing, transformation, input, control, and query functions. These are the different functions which are available and which are present in the APIs. So first one is the primitive function. It is primitive refers to the minimal, right? So low level objects are the atomic entities that our system can display. Attribute function, which allows us to perform the operation ranging from with the colors, right? Where we display, it can be a line or it can be any of the box or a polygon or any geometrical images, right? So primitive is older for use for the display. Attributes are nothing but what to draw, where to draw, those information. And viewing functions refers to how we are seeing. Are you seeing in the front, from the top, or from the side? All with the APIs. Next comes the transformation functions. So transformation function is used to change the particular shape of an object, meaning the when the object changes its shape, it is rotating or it is doing some animation, or it is changing its direction, or it can be movement of the object. So there are 3 things which object can do. Object can rotate, object can translate, and object can scale. So what do you mean by rotation? As we all know, when you rotate a color cube, it it can be rotated in x-axis, y-axis, or z-axis. Translation is nothing but moving of the object from one place to another place. Scaling refers to it can become big or it can also become small. So these are the major transformation functions. So next comes the input function. So meaning of the input function is getting the data from the keyboard or from the mouse to perform some activities, right? It allows us to deal with the diverse form of input that characterize the modern graphics system. So next comes the control function, where it deals with the communication, uh, whether to move forward, to come back, to come towards the left, to go towards the right, right? So using the graphics library, we can also write some wonderful programs, wonderful games, right? So today, if you use any of the, when you play any of the games, right? So we can use the functionality, right? You can move the particular object left or right, right? It can be any game, a car game, right? A car can move forward, a car can move towards left or right, or it can come back, right? Depending upon the controls, whatever you give, that particular program will be initiated, and whatever the errors will be dealt with during the execution. And the next one comes with the query function. The last one, the good API, provides this information to the set of queries, some questionnaires. So next comes the organization. You should see here on the right hand side, we have the graphics driver, right? So for any machine to run, we need a driver, right? So on the left side, we have the application program. We are writing some application programs where we may use extension Wrangler, that is GLEW graphics library, and we also have some graphics library utility toolkit. And all these things are combining towards for the library of X and X library and XT, and which are actually written for Windows here, as you can see, and the information will be sent to the graphics drivers. So how can I do this? The only thing is as simple as importing or including the things in the which we were doing in C programming. Dash include gl slash glut.h will actually import all the libraries which are needed for graphics library. Or some of the time when you're using free glut, so you can use the glut or glut.h. So these are the libraries which you can see, the GLU, GL, GLUT, and GLX. So all are will be stored in the frame buffer for the later use, and it will be sent to the display. So architecture of OpenGL looks in this way. We have the application program interacting with the graphics library APIs and interacting towards the drivers. These drivers are nothing but the controlling programs, right? So it knows how to deal with the keyboard when it is getting the information, getting the input from the keyboard. It also knows how to get the information, which key is pressed. Is the left button pressed, or the middle button is pressed, or the right button is pressed, or there is some scroll. So what should I do with any of the button when it's pressed? So the other thing is, for the output devices, the drivers will also understand how the television is, how the output devices or the monitors or the screens, right? So the drivers will help in order to display it on the screen. So speaking with respect to the coordinate systems, so units on the display were first called as physical device coordinates or just device coordinates. There are two types of devices: raster devices, right, or the random devices. For raster devices such as CRT and flat panel displays, we use the term window coordinates or screen coordinates. So this is one exam related question, mapping from vertex coordinates to the screen coordinates. See, we have the real world coordinates, meaning whatever our eyes see is called as a world coordinates, and whatever your screen, which can be put into the screen is called as screen coordinates. That is your monitor or a screen or a TV screen. It has limited space, right? Not everything which is available on the world coordinates can be mapped into screen coordinates. Why? Because we have the x and y minimum to x and y maximum, which you can see on towards the left hand side in the desktop of the world coordinates. In the screen coordinates, we actually see whatever has been sent from x and y has been converted or it has been shrinked to rs minimum to rs maximum. So this is important mapping from the vertex coordinates to the screen coordinates. Next comes our primitive and attributes, as we discussed. Primitive is used for displaying, and attributes is used to what is that you're displaying. It can be a line or a line segment or a dot or a point or a polygon or a curve or a surface. So these are the pipeline, which is simplified. We have the OpenGL program, which has to transform project clip and come to the frame buffer, or when it is not needed, the geometric
Sir.
pipeline.
ಈಗ ಇದು ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಅಂದ್ರೆ ವಾಟ್ ಇಸ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ಅಂತ ಡೈರೆಕ್ಟ್ ಕ್ವಶನ್ ಬರುತ್ತಲ್ಲ?
ಅದೇ ಹಿಂದೆ ಇದೆಯಲ್ಲ ಇದು ಬರುತ್ತೆ, ವರ್ಟೆಕ್ಸ್ ಕೋಆರ್ಡಿನೇಟ್ಸ್ ಟು ಸ್ಕ್ರೀನ್ ಕೋಆರ್ಡಿನೇಟ್ಸ್.
ಸೊ ಅಂದ್ರೆ ಈ ತರ ಡೆಫಿನಿಟಿವ್ ಆಗಿರುತ್ತಾ ಅಥವಾ ಆ ತರ ಡಯಾಗ್ರಾಮ್ ಬೇಸ್ಡ್ ಇರುತ್ತಾ, ಹೆಂಗಿರುತ್ತಾ?
ಏನಿಲ್ಲ, ಡಿಸ್ಕ್ರಿಪ್ಟಿವ್ ಬೇಸ್ಡ್, ಬಟ್ ಡಯಾಗ್ರಾಮ್ ನ ನೀವು ಬರೀಬೇಕು.
ಅಂದ್ರೆ ಅದೊಂಚೂರು ಒಂದ್ ನಿಮಿಷ ನೋಡಿಸ್ತೀರಾ ಸರ್ ಆ ಸ್ಲೈಡ್?
ಇಲ್ಲೇ ಇದೆಯಲ್ಲ.
ಅಲ್ಲ ಅದು ಇದು ಒಂದೇ ನಿಮಿಷ ಸರ್. ಇದು ಲೆಂತಿ ಆಗಿದೆ, ಅಂದ್ರೆ ಇದು ಫುಲ್ ಬರಿಬೇಕಾ ಹೆಂಗೆ ಸರ್ ಡಿಸ್ಕ್ರಿಪ್ಷನ್? ಅಂದ್ರೆ ಇದಕ್ಕೆ ಆನ್ಸರ್
ಕೊಡ್ತೀನಿ, ನೋಟ್ಸ್ ಕೊಡ್ತೀನಿ.
ಓಕೆ ಸರ್.
ಅದರಲ್ಲಿ ನೋಡ್ಕೊಂಡು ಬರೀಬಹುದು, ಏನೇನ್ ಪಾಯಿಂಟ್ಸ್ ಬೇಕು ಅಷ್ಟು ಮಾತ್ರ ಬರೆದ್ರು ಆಯ್ತು.
ಓಕೆ ಸರ್, ರೈಟ್. ಓಕೆ.
So how exactly a line segment can be actually printed? So in order to generate a line segment, we know that we need two things. One is from where I should start and where I should stop, right? So that is a point A to point B. It's called as a straight line between A and B is called as a line segment, right? You can also specify it as finite sections of lines between two vertices is called as a line segment. And yeah, there are many functions. For example, in primitives, we have functions related to points, line segment, and triangles. And in transformation, we have the viewing and modeling. We have some control when it comes to the GLUT input for the GLUT. Yeah, basic with respect to these. Yeah, when we look into any of the program, it will be with the form of function, right? And the function will actually be seen in this way. As you can see, I have GL uniform 3F. Everything has its own understanding. So what does this GL say? GL specifies that function uniform 3F is present in the GL library. So what is this uniform 3F? It's a function name. And what is this 3? 3 is specifying that it is a 3-dimension. You can also have it as 2AF. If it is 2, it is 2-dimension. If it is 3, it is 3-dimension. So X, Y, Z are nothing but floating point variables. So sometimes instead of X, Y, Z, I can also use a point, and a point can be an array of values where it is holding separately with X, Y, and Z values. So this is how a function format looks like in the OpenGL. So next we have, apart from GL, we also have glue, GLU, and GLUT, depending upon which library you are using. So when you include GL or GLUT.h, this will automatically include the other functions. For example, GL enable, GL depth test. GL depth test is actually used for a 3-dimension image. GL clear. GL clear is used for clearing the colors in the buffers to save the new colors. So include files also define OpenGL data types. So we have, apart from the program variables, data types, we also have graphics library data variables. So if you have a GL before float, double, int, string, char, it is used from the library. That's what it says. Next comes our, it's a bit chapter actually. Next comes about the shading. The shading is also supported in GL, where in order to get a realistic image, we go for OpenGL with the shading. And many of the hardwares, for example, NVIDIA's CG and Microsoft HLSL has been used for the graphics library for shading part, right? So this slide is, we can omit. Yeah, this is a simple program which has been used to generate the square on a black background. As we can see, we have a square box which is filled with white color. On the background, we have the black color which has been generated using graphics library. So how exactly has it has been generated? So this is a program which has been used to generate. So ash include gl/gl glut.h is used to get the input from the library, and we have something like my display. This is a function. My display is it's a function, right? And yeah, so in that my display, there are some specific set of points which you can see. So GL clear, meaning previously in that buffer some colors will be filled. You need to take off that particular color. So it has been taken off. So when you take off all the colors, what is that you have, right? So we have a black background, right? So next comes GL begin, GL quad, meaning GL quad refers to, you will be giving it, it is drawing a quadrilateral for the points whichever you give. So the next, there is GL vertex 2F, minus 0.5 to plus 0.5. Those are the points from where it has to start. So it has to start from minus 0.5 with the x-axis, minus 0.5 with the y-axis. That is the third quadrant. Then it is pushed to the minus 0.5 to plus 0.5. That is our first quadrant. Next comes towards 0.5, 0.5. That is the second quadrant. Then GL vertex 2F, 0.5 and minus 0.5 will be the fourth quadrant, right? So, and once you are done with drawing with these points, you have to specify that, yes, I am done with drawing the quad. That's when the GL end will come into picture. So next, as you all know, the program will actually start from main and int argument count and argument vector. So next comes the glut create window. You can see on top of this particular box, that is the window, you can see something called as simple, right? So that is the window name, right? That is the window name. Glut display function refers to my display, meaning from where it has to start, meaning what is the logic for your program. So when my display has been initiated, you can see that void my display, from there it will run. Glut main loop refers to, once it is done, do not erase it, let it be there. So glut main loop will be like, it will be repeatedly showing the same output, whatever it you have displayed. So this is basically the explanation. So this is simple and we have some loop might display exactly the same what I just told you. So I think we have come towards the half of the module. So what we'll do is we'll stop at this particular time. So yeah, we'll stop at this point.